Take a moment to read the following. How was that? Frustrating? Slow? What were those sentences about? They're actually a simulation of the experience of dyslexia, designed to make you decode each word. Those with dyslexia experience that laborious pace every time they read. When most people think of dyslexia, they think of seeing letters and words backwards, like seeing B as D and vice versa, or they might think people with dyslexia see saw as was. The truth is, people with dyslexia see things the same way as everyone else. Dyslexia is caused by a phonological processing problem, meaning people affected by it have trouble not with seeing language, but with manipulating it. For example, if you heard the word cat and then someone asked you, remove the C, what word would you have left? At. This can be difficult for those with dyslexia. Given a word in isolation like fantastic, students with dyslexia need to break the word into parts to read it. Fan, tas, tick. Time spent decoding makes it hard to keep up with peers and gain sufficient comprehension. Spelling words phonetically like STIK for stick and FRENS for friends is also common. These difficulties are more widespread and varied than commonly imagined. Dyslexia affects up to 1 in 5 people. It occurs on a continuum. One person might have mild dyslexia, while the next person has a profound case of it. Dyslexia also runs in families. It's common to see one family member who has trouble spelling, while another family member has severe difficulty decoding even one-syllable words like catch. The continuum and distribution of dyslexia suggest a broader principle to bear in mind as we look at how the brains of those with dyslexia process language. Neurodiversity is the idea that because all our brains show differences in structure and function, we shouldn't be so quick to label every deviation from the norm as a pathological disorder, or dismiss people living with these variations as defective. People with neurobiological variations like dyslexia, including such creative and inventive individuals as Picasso, Muhammad Ali, Whoopi Goldberg, Steven Spielberg, and Cher, clearly have every capacity to be brilliant and successful in life. So here's the special way the brains of those with dyslexia work. The brain is divided into 2 hemispheres. The left hemisphere is generally in charge of language and ultimately reading, while the right typically handles spatial activities. fMRI studies have found that the brains of those with dyslexia rely more on the right hemisphere and frontal lobe than the brains of those without it. This means when they read a word, it takes a longer trip through their brain and can get delayed in the frontal lobe. Because of this neurobiological glitch, they read with more difficulty. But those with dyslexia can physically change their brain and improve their reading. With an intensive multisensory intervention that breaks the language down and teaches the reader to decode based on syllable types and spelling rules, the brains of those with dyslexia begin using the left hemisphere more efficiently while reading, and their reading improves. The intervention works because it locates dyslexia appropriately, as a functional variation in the brain, which naturally shows all sorts of variations from one person to another. Neurodiversity emphasizes this spectrum of brain function in all humans, and suggests that to better understand the perspectives of those around us, we should try to not only see the world through their eyes, but understand it through their brains.